Okay. Fritz, you all right? Okay, good. Here we go, guys. Solving equations using addition and subtraction. Now, guys, the first thing we're going to talk about is inverse operations right here. Inverse operations. Inverse operations are operators that undo each other. Addition undoes subtraction. Subtraction undoes addition. Multiplication undoes. Multiplication reverses division, and division reverses multiplication. Okay? They sort of cancel each other out. They wipe each other out. So that's what inverse operations are. Okay? Equivalent equations. Guys, an equivalent equation is something like 5 plus 3 equals 8. They look alike, these two expressions. Oh, equivalent equations, I'm sorry. Let me do this. How about 2x plus 3x equals 7? No, equals, I'm sorry. No, I don't like that either. I'm going to get there, don't worry, guys. Here we go. Plus 7 equals 12. Okay, that's an equation. Here's an equivalent equation when I put the terms together equals 12. Okay, this is equivalent to this. When I subtract 7 from both sides and I get 5x is equal to 5, now this is an equivalent equation to that one and to this one. Okay, these equations, even though I'm changing the way that they look, they are equivalent. All right? Because if I have one side equaling the other, as long as I do the same thing to both sides, they still equal each other. That's the big deal with algebra. Okay? Algebra meaning balance. One side is balanced with the other. So to keep things balanced, whatever I do to one side, I have to do to the other. Okay? All right, let me get rid of that thing there because that's taking up too much space. And let's look. Subtraction property of equality and addition property of equality. Guys, I'm going to put, okay, look, there's Zachary. Zachary, there you are, looking good. Look at your hair. You need a haircut. Get a haircut. All right? And then let's see. We'll put Fritz up here. Okay? Well, okay. Come on, smartboard people. Oh, right, there we go. There's Fritz. Fritz always with a smile on his face. All right, there's Fritz. And then, let's see, Armand. All right, there's Armand. And then, yeah, let's go ahead and put Hobbs there. Okay. Now, that is the same thing. That's equal to Kai, right? Simon here. Let's go with Tut. Uh-oh. Let me put some plus signs between here. And then the last one, we're going to have to squeeze you in. Sorry about that, Alex, but you can't take up a lot of space. We're going to put you right there. All right? Now, these two equations are equal to each other, right? Okay. So if I take away Zachary. Oh, sorry, Zachary. Whoa, what happened to you? Zachary's gone. To remain equal, I've got to take away Alex or Tut or Simon or Kai for these things to stay equal. I subtracted the same thing from both sides. If I put two other guys over here to keep the scale equal, I've got to put two other guys over here. Come on, smartboard. Make it happen. Right? To keep things balanced, I have to do the same thing to both sides. I subtracted a couple of kids, one from each side, and I added a couple of kids to each side. Okay? All right, good. There we go. Now, that's the subtraction property of equality and the addition property of equality involving you guys. Okay? I can add something as long as I add it to both sides. I can subtract something as long as I subtract it from both sides. Now let's look at example number 1. Let's look at example number 1. This one says x plus 95 is equal to negative 372. And it says, guys, to solve. And here's what solve means, Trigo. It means get the variable by itself. Right now, the variable has a plus 95 with it. What will cancel out that plus 95? Teddy? Minus 95. But I have to do it from both sides or it won't work. When I do that, these two cancel and I'm left with x equals negative 467. Combine those two terms. Great job, guys. See you at the next example.